Apologies for not having posted for the last week or two. I've been working feverishly on this next segment and have a rather large data dump. You guys owe me big time. What we're going to be doing essentially, I want to make a custom font is part of this, right? And that entails a lot of things that we've already covered. So rather than do it the usual way where I build everything from the ground up, we're assuming that you have done a lot of that, and it's more about putting together a lot of pieces into a much bigger project. So to start, here, this is our new and improved pixel, right? Let's see what we got. Yeah, a little pixel at 4 in X, 4 in Y up there in the corner. Wonderful. For this one, I think we'll forget about our new and improved pixel and go back to our old and unimproved pixel. Pixel in the center of the screen there. Here I'm calculating the values manually into an index and using it there to draw our pixel. Okay, using the old-fashioned method because we will be doing some things with that data, so I want it accessible. Okay, so once we have that, then we can define our X and Y position, right? Simple enough. Oops. X and Y. Sweet. There we go. Same thing. Yeah. Here, of course, we take our Y position, do a little multiplication on it, times the screen width. I've also introduced a screen width variable so that each line is 320 down, and then add in the X to define how far over. Yeah, that's all stuff we've covered. Straightforward enough. Once we have that, X and Y position. Hang on here. Control. Okay, and I'm going to introduce a new variable. Our sprite size. I'm going to make a sprite that is 8 pixels wide by 8 pixels high. Since they are both the same, to save memory, I can define a single variable for both. Okay, so that is our sprite size variable here. Okay, so here we're going to be drawing a row of pixels, essentially, creating a loop. Hang on. There, draw a pixel. We're just going to keep drawing row of pixels until we reach, where is it? This many. Yeah, we're writing 8 into Sprite, into CX, and then run the loop, and it should draw, well, why don't I just show you? 8 pixels in a row. Yeah. Okay, so the next thing we want to do to define our a sprite. In the past, let's see, we have made a program. You can find it in your, if you've been following along in lessons, your print binary program, right? Where we take a value and then read the most significant bit, right, and determine whether it's a 1 or a 0, and then print out a 1 or a 0, right? There it is. And what we get, let me see, copy that into there. Prints out a bunch of 1s and 0s. Okay. So what we want to do is use this same binary information to instead print out pixels. So if it's a 1 or if it's on, we'll get a pixel, and if it is not, it won't print anything at all. It won't print black, it just won't print. It'll advance to the next and check if that is a 1 or 0. Okay, so copy that. Let's go back over here. Oops, what happened? Now, let's just have a look at that real quick. That is the same program. That is print binary. I want to print pixels. Hang on. There we go. Now we have printed a row of pixels. Basically, we are here. This value could be 42, could be anything. Here we're just representing it as binary data for our own convenience. So we can look at that and see that, yeah, it's 1, 0, 1, 0, 1, 1, the same as that. Yeah, 1-to-1 ratio, or a 1-to-0, 1-to-0 ratio, I guess. Yeah, so that's straightforward. We know all this stuff. Where to put this in X and Y, we calculated, right? And then here we're moving a pointer. Basically, we're pointing to the address. We're saying, look here on this line, right? Okay, there. And, oh, I'm sorry, no, not a pointer. We are loading what's in it directly. Oh, yeah, because it's in brackets. There we go. Okay, good. We'll be using a pointer shortly. How many to print? Sprite size 8, and then here testing whether they're 1 and 0. Yeah, here this is much easier to read. Before it said what was it? 8,000 H. Okay, same thing. Here, that's in hex there. So this is a little more explicit. We're testing the first bit, right? And then if it is a 0, we're just going to skip over the part that prints it. Down to here, right? And then we'll advance to the next one, right? And then go do another test, right? So it will only print the 1s each time. Yeah. Oh, yes. And shift left on this, so whatever value is in there moves over 1, and then now we're checking here. And then the next loop will check there, and the next loop will check there. Yeah, down the list. There you go. So it pulls the data from a single byte. Okay. Nifty. After that, so what we want to do is read from a string. Okay, so just to rehash, let's do a little blast from the past here. We should know how to do that now. There, we got some numbers here in our string data, right? And we're reading the data here using LODSB. Yes, and so that increments the index each time it reads a character in the string. It increments the index, and then we do a quick comparison to see if it is this 0, right? And if it is, then we bug out, right? But otherwise, we're just going to print our character. Jump to process string, and just keep looping that until we reach the null termination, and we are done. Good to go. Okay. So let me see. Okay, how to print a string. Okay, so then after that, in this particular instance, bringing all these pieces together can become a little overwhelming, and I found it helpful to take that knowledge and apply it in such a way that when I do my graphics, I can also print out some debug information on the fly. And that was critical in this to get to the final. It's like I understood all the parts, but then bringing them all together was quite complicated. And the only way to get to it was to be able to print out the debug information. The way I was able to accomplish that here, here I'm just looks pretty busy. Let's see. Print the text, move the cursor down a little bit, and then print the debug text. Okay, and then draw the graphics afterwards on top of all that. Okay, You can do it either way. You can print text on graphics or graphics on text. Okay, but essentially, if there's any text in the program here using a standard teletype function, see, and then you also want to print some debug data. Right here, I didn't bother with strings or anything. I just did the quick down and dirty, print some text, and then I want to go down a little ways. So you do that with here I'm doing a carriage return and a line feed, and I'm doing it over and over a number of times. So you get down here, and then we go and change the color there, right there, and then just a little bit of, you can say AH equals or whatever value this is supposed to be for debug purposes, and then go and print. Here I want to, just for demo, I printed the value that was in CX. Right, I move it into AX and then add the offset so it actually printed whatever the value was in there. So now I can debug things kind of on the fly, see what's going on at the end of a segment. So that was kind of critical in bringing all of these complicated things together. Let's see. So once you got that, in the text and graphics, I mentioned you can put graphics on top of text or text on top of graphics, right? Let me put some text on top of graphics. First, let me just take this down to 25. So, whoops. And there. So now it's covering that bit up. Okay, let's get the graphics underneath, which is just a simple matter of going up here where I call it draw square, cut, and put that up here before I print the text. There. All right, let me just see what we got now. There, observe the text has a background, right? And if you're in 16 color mode, then you can set that background color independently from the text and make it blend. But apparently you can't do that in 256 color mode. If anybody knows a way, I have a suspicion it's in there somewhere. It's just like somebody forgot to write it down. Yeah, but so that's where the whole custom text comes in. Apparently, if you want to write over an object and you don't want to print those pixels, then you have to go through the trouble of defining your own. These are in memory somewhere too. That's another thing of interest to me. Somewhere in hardware, in read-only memory, is this complete list of fonts that the computer is grabbing and outputting these. So I should be able to find that address. I haven't been able to figure out how to do it. If anybody has that, feel free to post it as well. Where on the x86, right? Where in this is this in read-only memory? Because it could save some time to just go and read these pixels right out of memory and then print only the pixels over something and create your own alpha channel without having to go through the trouble of creating your own custom fonts. So that's of interest to me as well. Not a huge deal for the most part. You just kind of get used to that, I guess. For now, yeah. So another minor little detail. Okay. Let's have a look at this. Yeah, okay. So now, instead of reading from a single byte, we're taking that, what we just used in a string, where we are kind of iterating through each of these consecutively. We don't need the null termination here. It's kind of hard to use null termination with all these zeros. Instead, we're using the known value, which is our sprite size. So it will, it knows that the data is 8 bytes wide. So remember, each of these is represents 8 bits, right? So here I printed them consecutively, which is pretty much what's going on in our code here, where we have this long line of code that wraps down to here, right? Okay, so if that got bigger, then this could just go way off the screens and everything. So there's another way to organize that. Let me, but first, okay, we got these printing out consecutively. In order to organize them into an actual sprite, we want the next, after we print 8, we want the next row to be down 1, which is screen width, right? Add screen width times 1. That brings it down to the next row, and then subtract 8, and now the next successive row will be under the first. Yeah, so in which case, oh, did I scroll through all the code here? What is, so if I do this, I'm just going to get rid of the screen width, right? Add in the screen width, subtract sprite size. There we go. Save that. I made it easy on myself. Bada boom. There is our sprite. Yes. So having all that under our belts, let me just verify you have everything. Top of program, bottom of program. Yes. Okay. Once you got that, that is an 8x8 sprite. It is a simple matter if you want to make a bigger sprite. Oh, one thing here. Also observe here, I started to say you have a long string of binary bits, and what you end up with over here is a stacked binary bit. So of course you can take this and visually make it a little easier on yourself by going, oops, kind of lining them all up a little. Here, let's go space there. Okay, and then, oops, hang on, I didn't mean to do. I meant to like that. Yeah, there. Okay, so now I can just go. Return db space, whoops, db space, etc. You see, db space. Yeah, now I'm getting the hang of this. Can I just double click? No, that only selects a space. db space. Just a couple more to go, folks. db space. You see, so now it's more visually representative of what I've got going on over here. db space. See? Yeah, see? Bunch of 1s and 0s, bunch of 1s and 0s. See? So now you have a 1 to 0 relationship between the two. I can save that and render it, but it's the same thing. The data. All just here what we can do. It's like if you go and look. Whoops. Sorry. At our binary, it is, it's just a bunch of long row of linear numbers that there is no beginning and end. All we determine where to look, and the way we do that. So once we have our pixel, right? It's 8x8, very nice. It's a simple matter to extend that to whatever size sprite we want. In this case, I'm moving to a word, and now it is 16 bits wide, and all I have to do really is up my sprite size a little. Here, let me just top half of code, middle, end of code. There. So let me just save that. Not that. Yeah. So now you have not more detail, just it's the same amount of detail. You just have a sprite which is twice as large, so you can define different objects, in your game or whatever. Okay. So having that out of the way, Next, I'd like to, let me back up one. Let me go back to my regular sprite. I can just go undo here. Yeah, there's my regular sprite. Save that. Yeah, you know. So here, where's my sprite data? Yeah, yeah. Once I have my sprites, you know, let's say I want to define an alphabet, you know, and I can make the character A here, and then the character B, and the character C. Okay, that's easy. We can do that. We can just change these around. We got our A. Okay. But what I inevitably want to do is I'm going to be able to take string data, read it, and then print out the characters relative to these data maps that I've created, right? Not only that, but I want to make sure that they print out at the correct place on the screen, right? So jumping kind of ahead a little bit, we're going to want to map that out where all of these sprites are going to fall, or that can be another brain fry. So in this version, I basically do the layout, you know, and set it up so, knowing that each of our sprites is 8 pixels wide by 8 pixels high, right? But keeping in mind that when you lay text out, there's also a little bit of space between one line and the next, so you add in an extra 4 pixels or so for line spacing. Leading, right? Here, this is funny. I told Chat GPT, hey, I need a sentence with 44 characters, with 52 characters in it. So it goes, okay, this is a string with 52 characters in it, ... And then I render it. It's only 44 characters. You know, it literally, like, makes jokes with you sometimes, you know, testing your limits of human patience. They're testing us. Okay, so there is the alignment thing, where what I'm doing is looping along, printing these in the correct spacing, and I am determining how many to print from how many characters there are in the string, right? So I'm going through incrementing SI, and then print a sprite. Right, and then increment SI, and then print a sprite, and every time. See, so what it's doing is counting how many characters there are in this string, and that's how many pixels it prints. See, it goes count this character, print a pixel, count this character, print a pixel, count. See, so that way I was able to make a 1-to-1 ratio between the number of characters in the string and the final printout. Okay, so there's the, let's see, top of that program. And all the way down to there is that program. See, so then once you got that, you can kind of just pencil in like a little dummy sprite, I guess, to test the water with and make sure you got all your placement correct. See? So there's our little sprite in place, right? Start up here. Now I am actually scrolling through the index. Where is it? Grabbing the sprite data, you know, and then moving it over, loading the appropriate character, right? Let's see, where is that? This is the part that all draws pixels, draw the row, draw the sprite. Okay, here. Yeah, you also have to back up that data. All right, because here, this is when it starts getting really complex. You know, you're using some registers up here, and then now you got a module that you've made, you know, so got to make sure you're not overwriting something. We're going to reuse it, right? Okay, so yeah, next position. Yeah. So we have our exposition of our character. We add the character width, right? And then keep adding that, right? We keep adding that back in. So each time it adjusts where it's going to print the next one on the screen, right? And then also we're checking that screen width there for wrapping. Whoops. So when it gets to there, it will reset it down by the height or character size. It'll be 8 pixels down, plus a little. There's a 4. Add an extra 4 in there. Maybe 3 might be better, but 4 is a nice even number. Okay, there. So now we have printed out a number of the same sprites, right? Now we need to go in there and index our data from strings, okay, which again can be mind-bogglingly complicated, because now instead of the data being this long, it'll be like a mile long. How do you organize all that? Okay, so what I've done is create a 2-dimensional array. Okay. There. Okay. So here I have a value. Let me just do this, run it real quick. It prints this. It prints this. Right, if I change this value to a 1, it prints that, you see? And if I change this to a 2, it prints the other, you see? So now what I'm doing, I got an array of strings going here, right? And they each can be signified by what row they are here, using BX to represent which row of data to look in. All right. So then we can cycle through each one until we hit a null terminator, and then check here if we've reached, if we've counted down to the value of, if the counter matches whatever row we're in now, then print that row. Okay, wow, complicated stuff. Okay, so once we have that, did I show you? Let me see. Top of code. That's pretty simple, pretty straightforward. 2-dimensional array using an index number. I can access any one of these. Okay. So here we go. There's our final. Now, although it looks like I am just printing some text on the screen, I am actually printing text that I have custom defined. And we can verify that by, let me just grab my other sprite here for a second, one of my previous custom sprites, and we'll write over our 0 here. Paste there. So now, there. So we can completely define our own custom sprites. They can be numbers, they can be letters, they can be little characters. We can do 8-bit sprites, we can do 16-bit sprites, we can put them anywhere we want on the screen. This is here's a new command here. Basically, I've created, same as here, I have 8 bits of sprite data, yeah, that we used previously, yeah. So here, I've duplicate 0 is kind of like times, but I'm putting it into the data. So basically making an array of 8 zeros, right? And then I can take any one of these and overwrite the sprite data, right? And then just print it normally, as in the previous experiments, without having to change anything. So this is a very complex process where I went ahead and made the extremely complicated program, combining all of this stuff together. And in order to do so, you have to kind of go back and change SI to DI, or DI to SI, and change this and move that and push that and pop that in order that all these little modules do not conflict. So you reorder a lot of the elements of the program. But once having done that, I go back and work chronologically backwards and deconstruct the master program so that now I have all these individual modules and bits and pieces, right? In other words, if I got to this point and I had to change a bunch of stuff, right, and I had been doing this video tutorial for y'all, right, and then in the final I got to go, I got to change this, and I got to change that, and I got to change it. That looks all very disorganized, right? So, but instead, if I take the big complicated program and work backwards to the simplest elements now I can show you how to make all those parts, and they all kind of seamlessly snap together into the master program, which is kind of what I've done here. So a lot of the programs in this segment, although we've done a lot of it in the past, I might have changed little bits in here and there, so now it all just kind of fits together. I haven't showed you the whole code. Okay, process string. Yes. So we go through our string, load the data, and when we have reached the null termination, we're out of there. Once we have our data, we can convert it with so it's printable, right? Oh, no. Actually, the opposite. We are taking printable data that's in a string, and we want to convert it back to a raw number. Yeah. Once we've retrieved it, see, we're doing our comparison here. If we converted it to a raw number first, then one of these zeros would immediately conflict with our comparison, right? So we do that afterwards, right? So now the value that was actually 48 in our string data representing 0 now becomes the actual 0. Okay, once we have that, then we can use those numbers to say which one of these we want to access. All right, okay, so let me back up. Okay, select font data into sprite data. Okay, we want to point to the font data, the address of the font data. Okay, here. Okay, so that's like our index, all right? And then we know each character is 8 bytes in size, so we can use that to get to a specific character in our font data, you see, just by multiplying by the known number of bytes in it. And then once we have that, then final calculation stored in SI, then we can move on to okay, we got the number. Now we want to use that as a comparison to know where to look in our other data, the font data. See, we're taking sprite data, right? Font data, font data. Now we're grabbing from sprite data using the value. And to do that, there we go, SI tells us which byte. And then move to the next byte, the next byte, the next byte, next byte. There you go. Repeat all 8 bytes. Okay. Complicated stuff. And when we did that, we might have overwritten a register or two, so we want to ensure that we save that. So then when we get out of there, it's all back to wherever it was. Return. Okay, so that was font data. Then what do we call? Then we draw our character. Oh, draw our character. Same thing. You know, we have segments here that all only use a limited number of registers. So each time we call one of these complicated subroutines, you know, push all the data that we're currently trying to hang on to, then do all these calculations, and then put it back. Okay. Here, I haven't even bothered to. Usually I do this at the top. We're not doing any graphics up until this point, you know, so we'll go ahead and set ES here so that we can that is our video segment, you know, and now we need to set DI here. Where on the screen, you know, I have provided a Y value and an X value, which is down here, like 150, 0. 0 and X, about approximately. What is the screen is 200, yeah, about 150. What did I put in there? 120, 0. There you go, okay. There we go. So all of this is where to put it on the screen. Right, and then once we get there, we initiate our sprite drawing routine where we draw the first row, pixel per pixel. Right, if it's a 0, skip over. Okay, down to there, and then do the next row. Yep, and draw, jump back up to here. Draw the next row, increment, draw the next row, increment, until that is done. All right, return. Okay. There we go. What else? Let's see. Font data, draw character, update position for the next character. That is the part that we just did where we printed a bunch of pixels to the screen that tell it where exactly to print each successive character, one after the other. And here we're checking for wrapping, you know. If it goes off the screen, then set it back. Okay. And if there is no wrapping, then skip over that part to here, and we're done. There you go. So now I can put a very, very, very long string in there, and it will wrap down there. I can customize the fonts any way I want, and there we go. Wow. Okay, that is that, and everything else, and this is kind of based on that, and or expanded outwards from that. Once I have my custom fonts. Let me see here. String to custom fonts. Oh, okay. So then, let me just back up a little bit if I can. Can I just undo? Let me just do this the easy way. I just want a sprite. Give me a sprite. Here's my sprite. Okay, once we've gotten to that point, let me just render this real quick. Okay, there's our black and white sprite defined out of pixel data. Okay, what if we want this black and white sprite to be color? Okay, so then what we want to do is define color data. Here, instead of this just being a 1 or a 0, now it can be a value. Okay, now that could take up a little room. So let me here. I am kind of compressing the data using words. So this bit will let me render it. There's our color sprite now where I am storing color data instead of just ones and zeros, right? So it runs through, and here I'm using a single word to represent 4-bit color. So this is 16 colors, right, from 0 to 15, yes. And that'll be the first pixel, that's the second pixel, that's the third pixel, etc. And again, you could, so 1, 2, 3, 4, I could break it up, something like that. Yeah, more like that, right? But, you know, well, yeah, that does help a little, doesn't it? Yeah, it was, so as you can see now, it's 8 bits wide, right? But defined by 4 words, you see. Yeah, so that's just tightens it up a little bit. And there's your color data. Also, oh, well, let me show you the whole program. For starters, top, all of that is common stuff down to there. X and Y, draw the color sprite from, set the pointer to the color data array. We know number of rows is 8. Draw each row, load the value, each one successively. Then here's where we break it up, so we can just get to the, by shifting right, we get either the higher 4 bits or the lower 4 bits. Right, so we get one, then the other. That allows us to separate the colors, and then once we have that, we print the color. There you go. Now here, skip if the color is black, right? So that allows us here to, we can define an alpha channel, basically, right? So I could say compare AL here to, here I've got 0, but you could compare it to any color. I could compare it to OEH, right? And if it's that color, then we will skip over the part where we print the actual pixel. So what happens is, essentially, in this version, when it's 0, anything that is black will not be printed. So if you have a sprite that goes over some scenery or something, you know, then, or let's say you want to make a round sprite, you know, but then when it goes over something, you don't see those black square edges, right? You just make it so it doesn't print those there. Yeah. So that is alpha channels, defined from color data, in 4-bit. Great. Okay, so once you have that, we can extrapolate that just a step further and go with the 256 color data. Word, here we're using word values, yeah, and it's the same. It's essentially, these two are the first, second. So here, let me just save that out. Yeah, so we have quite a palette of colors there. 256 colors. Oops, hang on. Let me render that again. So here, see that top left-hand corner pixel is 12. It's a dark color. So if I want to make it white, I could just change that to OF. And that should make the top left-hand pixel white. There, see? So there you can, remembering that this is 8 pixels wide, but it's bytes. Nibbles. It's stored in nibbles, a higher nibble and the lower nibble, you know. So that gives us 8 per row of 256 color. Okay, let's look at the entire code here. Top, color data, point to the color data, number of pixels per row. where to put it on the screen, draw the rows, okay, and then here we deal with transparency, and we have made it black. Yeah, and then if not, skip. Yeah, whether to print it or not print it, and then advance to the next. So pixel, pixel, pixel. There you go. In 256 color mode. So here, let me freeze. Top half of screen. Middle. Bottom of screen. There. So you got all the code. So yeah, bringing all that was crazy brain fry. So hope you can utilize some of that. Like my good friend Ray Manzarek, keyboard player for the infamous rock band The Doors, used to say, our motto was, we're taking over, to which I would reply, oh yeah, well, if not by any other means than by attrition. Yeah, very sad. I was like, okay, well, here, let me put your money where your mouth is. So I managed to finagle him an open invitation to the Bohemian Grove, and we could have just waltzed in there during one of their get-togethers and been sitting round table, toe-to-toe with the wealthiest, most politically powerful and influential people on the face of the globe, just hanging out, sipping cognac and smoking cigars under 3,000-year-old redwood trees, and shooting the Schlitz beer cans and just talking about the future of global politics, but he left us far too soon. I was at one of his very last concerts when he was up there on stage just doing this like musical number chant and talking about how cocaine was eating him up. He just couldn't stop. He couldn't stop putting in his arms and in his nose, and it was killing him, and unfortunately, before he could take me up on the offer, he left us, not long after that. Truly tragic. I honestly felt like at that point in time, I could have made the man a U.S. senator. He was intelligent. He was charismatic, sometimes the dominoes are all set up to fall and doesn't just work out the way you think sometimes, but yeah, tragic end.